That star you're looking at right now, it might already be dead. And you'd never know it. Because everything in the night sky right now isn't actually now. Picture this. You're lying on your roof, staring up at the stars, thinking you're seeing the present.
You're not seeing their present. You're seeing their past. And this isn't philosophy, it's physics. Today, I'm going to show you that if you look in the right direction, you can literally time travel.
Okay, let's dive right into this explainer. Think about the light in your room right now. It reached your eyes in literal nanoseconds, right? So to us, it feels completely instant. But you know, the moment we look up and beyond our own atmosphere, that whole concept of real time just completely shatters.
Now, think about the sun. Our own sun is about 150 million kilometers away from us. And at that massive distance, light is definitely no longer a matter of nanoseconds.
Section 1. Our sun's 8-minute ghost.
The light from the sun takes exactly 8 minutes and 20 seconds to reach you. I really want you to just let that sink in for a second. You have literally never seen the sun as it is right at this very moment. Honestly, if the sun vanished right now, like this exact second, we wouldn't even know for 8 whole minutes. You'd just keep seeing a sun shining up there that doesn't actually exist anymore. You'd basically be looking at its ghost.
Section 2, neighboring stars in the past.
And you know, 8 minutes is absolutely nothing compared to what's coming next. Let's zoom out. I mean, way, way out, far past our sun and past our entire solar system. Say hello to Alpha Centauri. It's our closest neighboring star system, but its light still takes 4.2 years to cross the void and reach us. Because of that huge delay, right now, you're actually seeing its 2022 self. So whatever has happened over there since then, well, you have absolutely zero way of knowing. Not yet, anyway.
Part 3, the light of Polaris.
Now let's go even farther out to a star you've probably heard of, Polaris, the North Star. People have used it for centuries to navigate ships across the oceans. But get this, its light is 433 years old. When you look at Polaris tonight, you are seeing some genuinely ancient light. You are seeing light that actually left the star all the way back in the year 1593. To put that into perspective, William Shakespeare was literally still alive when that exact beam of light began its journey toward Earth.
Section 4, light from before humanity.
But guys, that is still just a warm-up, because right now comes the real mind-bender of this whole explainer. If you look up at a really dark sky, you might just be able to spot a faint smudge. That is the Andromeda galaxy, and it is the absolute farthest thing you can possibly see with just your naked eye. And its light is 2.5 million years old. Seriously, let that massive number just wash over you for a second. 2.5 million years. This means when you look at Andromeda, you are literally seeing light from before modern humans even existed. We were still evolving back in Africa when that specific light began its epic journey towards your eyes. Think about it like this. That single photon has been traveling nonstop for millions of years through the total vacuum of space with one single purpose. Just to reach you. It traveled all that way just so you could glance up at the night sky and see it, even if just for half a second. So really, you are intimately connecting with the deep past every single time you stargaze. Section 5. Telescopes as time machines. Everything we just talked about, that's just with the naked eye. Now imagine what happens when we use a real telescope. Because telescopes, they don't just zoom in on distance in space. They literally act as a window, zooming backward into time itself. So if the naked eye can look 2.5 million years into the past, it leaves us pondering one really staggering question. Let me show you exactly how far back into the origins of the universe scientists have actually seen.
Welcome to the Explainer. Okay, today we are diving into something that is, quite honestly, one of the most mind-bending concepts in all of science. We're talking about the actual nature of time itself, and we're going to explore it by looking through humanity's absolute most powerful eye on the universe, the James Webb Space Telescope. Trust me, by the end of this, you are going to look at the night sky completely differently. Okay, let's dive into this. Back in 2022, James Webb captured something that literally stopped the entire scientific community in its tracks. You've probably heard of it. It's called the Deep Field Image. But to really grasp what a massive achievement this is, we've got to wrap our heads around exactly how much of the sky we're actually looking at here. So try this. Imagine walking outside on a super dark night. You pick up a tiny single grain of sand. Now pinch it between your fingers and hold your arm straight out against the sky. That incredibly tiny speck of blackness that your grain of sand covers up, that is exactly the amount of sky the telescope was looking at. Just an impossibly small sliver of the cosmos. And here is the crazy part. In that tiny patch, literally one grain of sand's worth of space, scientists didn't just find a few stars. They found thousands of galaxies. Thousands, just sitting right there, packed into that microscopic pinprick of the dark. But honestly, the sheer volume of galaxies isn't even the wildest part. It's how old they are. 13.4 billion years. Some of those galaxies are so incredibly far away that the light we are seeing from them right now, it's 13.4 billion years old. Let's map that timeline out to put it in perspective. The universe kicked off with the Big Bang, right? Well, because that light has been traveling toward us for 13.4 billion years, it means we are seeing those exact galaxies as they were just 300 to 400 million years after the Big Bang itself. It is a literal baby photo of the universe, just completely frozen in light. Which kind of leads to this slightly haunting realization about what's actually out there today. I mean, 13.4 billion years have passed since that light was emitted. Those galaxies, they probably look absolutely nothing like that anymore. Over billions of years, they've morphed, they've crashed into each other, merged, and yeah, inevitably, some of them have probably died out entirely. Now, what's really interesting about this is a beautiful concept known as childhood light. We are not seeing these galaxies as mature, modern structures. We're seeing their childhood. And that's simply because the light they gave off all those billions of years ago is only just now hitting our telescope's lens. That light has literally been running a 13.4 billion-year marathon across the void. So, I really want you to just sit with this next idea for a second. When you look through a telescope, you are not just looking out into space. You are looking back in time. Space and time are so intimately linked by the speed of light that looking deeper into the cosmos means you are literally looking deeper into the past. And hey, that's not just a cool metaphor. It is a hard, undeniable law of physics. Every single time. No exceptions at all. Whether you're peering at a galaxy 13 billion light-years away or literally just glancing up at our own moon, you are seeing it as it was in the past because light always takes time to travel. Okay, once you really lock in on that idea, that looking up means looking backward, something even crazier starts to make sense. Let's completely flip the perspective for a minute. Instead of us looking out into the dark, imagine someone out there looking back at us. Picture an alien civilization, somewhere way out there in the vastness of space. And let's say they're positioned exactly 65 million light-years away from Earth. That means it takes exactly 65 million years for light to cross the gap between our planet and theirs. So here's the ultimate question for you. If that civilization built a telescope infinitely more powerful than the James Webb and they pointed it straight at Earth right now, like today, what do you think they'd see? They would see dinosaurs, literally, actual dinosaurs walking around on our planet. They wouldn't see our cities. They wouldn't see human beings. They would see a prehistoric Earth just teeming with giant reptiles. And this brilliantly illustrates how it's a perfect two-way street, just like we're looking at 13.4 billion-year-old baby galaxies because their ancient light is just arriving here. Distant observers would see a 65 million-year-old Earth. The light that bounced off a T-Rex 65 million years ago, it's only just reaching their alien telescope right now. This sets up a theoretical concept that is just absolutely incredible. Light leaves an event on Earth, travels harmlessly across empty space, and is eventually intercepted, which means, theoretically, if you had a powerful enough telescope and you could somehow instantly transport yourself far enough away, you could watch Earth's entire history play out like a movie. History is quite literally out there on display across the universe. By just adjusting how many light-years away you stand, you could watch the day of your own birth. Step back further, you could witness the asteroid that caused the extinction of the dinosaurs. Everything that has ever happened here is out there. It's like a cosmic recording floating in space, forever on repeat, just waiting for anyone with the right lens to tune in. So the crucial point is that every single moment that has ever happened, its light is still out there, traveling, right now. That light didn't just magically stop because the event was over on Earth. Nope.
It is still moving through the universe at 186,000 miles per second right this very second.
Which leaves us with a truly profound conclusion. Technically speaking, the past never really ends. It just gets farther and farther away. Every laugh, every massive triumph, every dinosaur, it is all still out there, forever etched into this giant cosmic recording. So the next time you look up at the night sky, maybe ask yourself, what past are you looking at? And who might be out there, right now, watching ours?
If you think you know what you're looking at when you step outside at night, well, prepare to have your perspective entirely shifted. Okay, let's dive into this.
So, what are you actually looking at when you look at the night sky? I want you to really think about this for a second. You step out onto your rooftop tonight, you tilt your head back, and look up into the dark. What exactly is hitting your eyes? Most of us just intuitively feel like, we're observing the universe exactly as it is right now, in real time. We assume those stars are shining up there right in this very moment, kind of like cosmic streetlights. But what if I told you that literally couldn't be further from the truth?
Section 1. The illusion of now.
To understand what's really happening when we look up, we got to start with how we experience light in our normal everyday lives. Quite literally, the light in your room right now is lying to you. Think about it. When you flip a switch, the light reaches your eyes in nanoseconds. Because it happens so unimaginably fast, it just feels instant. Your brain tells you that you're seeing your room exactly as it is right this very second. But that instant feedback loop, it's just a local trick. Because the moment you look out your window and into space, the rules completely change. And this brilliantly illustrates that massive shift in scale. Think about your room light reaching you in mere nanoseconds. Now compare that to our own sun, sitting roughly 150 million kilometers away. Even traveling at the absolute speed limit of the universe, the sun's light takes 8 minutes and 20 seconds to cross that distance and actually reach your eyes. Just let that sink in for a moment.
Section 2. Zooming into the past.
That 8-minute delay is fascinating for sure, but honestly, our sun's delay is just a warm-up. The further out we look, the deeper into history we go. Think about the practical reality of that solar delay for a second. If our sun were to magically vanish right now, this exact second, we wouldn't even know about it. For 8 whole minutes, the sky would still look perfectly bright. You'd keep seeing a sun that doesn't actually exist anymore. You'd literally be standing in broad daylight looking at a ghost.
Now, let's zoom way out, way past our solar system, to our closest neighboring star system, Alpha Centauri. The light from Alpha Centauri takes 4.2 years to reach us. So if you point a telescope at it tonight, you aren't seeing it as it is today. You're seeing its 2022 self. Whatever has happened to that star system since then, maybe they discovered sourdough baking. We don't know. You have absolutely zero way of knowing. Not yet, anyway.
Let's go even farther to a star you almost certainly know, Polaris, the North Star. For centuries, humanity used this exact star to navigate ships across vast, dark oceans. Well, its light takes 433 years to reach Earth, meaning when you look at Polaris tonight, you are seeing light that left in the year 1593. William Shakespeare was still alive, walking the streets of London when the light hitting your eye tonight first began its journey. Insane, right?
And now for the real mind-bender. 2.5 million years. That is the light travel time from the Andromeda galaxy, which, by the way, is the farthest thing you can see in the night sky with just your naked eye. When you look at Andromeda, you are seeing light from before humans even existed. We were literally still evolving in Africa when that specific photon of light began its journey. It has been traveling non-stop through the freezing vacuum of space for millions of years with one single purpose, just to reach you, so you could glance up and see it for half a second.
Now, what's really interesting about this is how it completely reframes the tools we use to study the universe. Everything we've talked about so far is just what you can see with the naked eye. Imagine what happens with a massive observatory. A telescope is not just a high-powered magnifying glass. It's a literal time machine. The deeper into space a telescope looks, the farther back into the history of the universe it is peering.
When you lay it all out, you can really clearly see this progressive journey of light. From the nanoseconds in your living room, to the 8 minutes of our sun, to the 433 years of Polaris, all the way back to the 2.5 million years of Andromeda. Looking into space fundamentally means looking back in time. Every single point of light is just a message from the past.
Section 3. The expanding universe. But here, we have to execute a massive pivot, because all of this time travel depends on light eventually reaching us, and it's a big one, because the universe isn't just sitting still, it's expanding, and it's expanding fast, faster than you'd ever imagine. Some galaxies are so far away, the space between us and them is actually stretching faster than light can travel.
Which means their light will never reach us. Not today, not in a million years, not ever. There are things in this universe we are permanently, forever, cut off from seeing, their entire past, hidden from us, forever, by the very expansion of space itself. It's pretty sobering when you really think about it.
And here's the flip side of that same coin, which is even stranger. Whatever you think of as the future, someone else out there is seeing it as their past. This layered, endless game of time and light never actually stops, not for anyone. Every observer in the universe is trapped looking at everyone else's past forever, including you, including me, including everyone who has ever looked up at the sky.
Section 4. The Cosmic Photo Album.
So let's bring this all the way back down to you, right now, on your rooftop. So the crucial point is this. The next time you look up at the night sky, remember this one thing. You are not looking at the present. You never were. Not even once. You're looking at a cosmic photo album. Every star from a completely different point in time. Some from right now, some from centuries ago, some from millions of years in the past.
You are, right now, with your own eyes, time-traveling without moving an inch. It's a profound realization. You are standing perfectly still, yet you are bearing witness to the deep history of the cosmos. Which leaves us with one incredibly provocative question to think about the next time you gaze up at the dark. If every star you see...
Dive right in. So, to start, I want to pitch you a thought experiment that absolutely bends how you think about reality. What if we could put a giant mirror out in space, let's say exactly 1 light year away from Earth, and just point it right back at us? I know, it sounds totally like science fiction, but it actually perfectly illustrates a fundamental role of our universe. Here's how that would play out. First, you send a light signal out to that mirror. Now, because it's exactly 1 light year away, it takes 1 full year for that light to actually hit the glass. Then step 2, it takes another full year for that reflection to travel all the way back to your eyes. So what's the result of all this? Well, if you looked into a telescope at that mirror today, you would literally watch your own actual past unfold in real time, exactly as it was 2 years ago. And the absolutely crucial point here is that this isn't some memory. It's not a digital recording. You're interacting with actual physical light bouncing back, showing you a real moment that already happened. You've literally built a time machine. Section 1. The Cosmic Time Machine. Now, obviously, we don't have giant space mirrors floating around, but the universe kind of acts like one anyway. The formal term for this is look-back time. It's basically the built-in delay of light traveling across the vast emptiness of space. Look, light is incredibly fast, we all know that, but space is just so unfathomably huge that the light from distant stars and galaxies takes years, thousands of years, or even billions of years to actually reach our telescopes. Because of this look-back time, every single time you look up at the night sky, you are literally looking deep into the past. And once you truly wrap your head around that, you start realizing it applies to a whole lot more than just your average twinkling star. We're talking about gravitational lensing. You know how massive objects, like entire clusters of galaxies, have gravity so intense that they actually warp the fabric of space. Well, that ends up bending the light from objects sitting behind them. And because this light is forced to take these different bent paths of varying lengths to reach Earth, it actually arrives at different times. So astronomers can point a telescope and see the exact same galaxy appear multiple times in a single photograph, but at completely different ages. It is literally like looking at someone's baby photos and their graduation photos sitting right next to each other, side by side at the exact same moment. How crazy is that? Section 2. The Universe's Instant Replay. Scientists have actually found real-life versions of that mirror thought experiment out in the cosmos. Some of the light we see today is bouncing off cosmic dust clouds, replaying old explosions for us. Think about a massive star going supernova. That incredibly bright light travels outward. Sure, some of it comes straight to us, and we see the initial explosion. But some of that light shoots off in other directions, hits these massive clouds of cosmic dust light years away, and then reflects back to Earth way, way later. It's the universe's own version of a delayed instant replay, playing on repeat for centuries. We call these light echoes, and they are absolutely real, observable phenomena. Up until now, we've mostly been marveling at the awe-inspiring magic of peering into the past. But now, let's talk about something a little more unsettling, the future of the night sky itself. Because you see, all of this look-back time means our sky is actually playing a bit of a trick on us. Section 3. A glimpse into the future. Let's look at our neighbor.
Right now, Andromeda is heading straight toward us, set to collide with the Milky Way. But the Andromeda you're seeing tonight isn't where it actually is right now. We are seeing it as it was roughly 2.5 million years ago. By the time this collision actually happens, in about 4.5 billion years, everything will look different. The entire structure of our night sky is going to be torn apart and merged into a completely new, totally unrecognizable galaxy.
Section 4. The Fading Cosmos.
And this is where things take a much darker turn. The universe isn't just sitting still, right? It's expanding. And that expansion is actually accelerating. As galaxies move faster and faster away from us, the physical light waves they emit actually get stretched out over time, a process called redshift. And here's the darker part. The universe's expansion means most galaxies are speeding away from us. Billions of years from now, their light will stretch out and fade completely from view. Just think about this timeline for a second. Right now, at year 0, we've got this vibrant sky packed with visible stars and distant galaxies. We can look out, map the cosmos, piece together our history. Step forward 4.5 billion years, and you get that massive collision with Andromeda we just talked about. But trillions of years from now, that universal expansion will have pushed almost every other galaxy so far away and moving so incredibly fast that their light literally can no longer reach us. The universe itself will still be there, but the visible light from the wider cosmos will simply stretch out and fade into total emptiness.
Section 5. A Temporary Privilege.
It is a pretty stark reality to confront. Future civilizations on Earth may look up at night and see almost nothing, just emptiness. They won't know about other galaxies, they won't know about the Big Bang or the cosmic web, because the evidence, the physical light from those distant objects, will have been quite literally erased from the sky. They'll probably think our merged Milky Way Andromeda galaxy is the entire universe, just floating alone in an endless dark void.
Which means the night sky full of stars that you're looking at tonight is temporary. You, me, everyone alive today, you are living in one of the only eras where the universe still lets us see this far back. We are so incredibly lucky. This window into billions of years of cosmic history is wide open for us right now, but it won't stay open forever.
So every time you look up, you're not just seeing the past. You're witnessing a privilege, a window into billions of years of history, one that won't stay open forever. So maybe take a moment tonight. Step outside, look up, and really appreciate the view while it lasts. Thanks for joining me on this explainer. I'll catch you next time.
Like the video. Make sure to hit that like button and subscribe for more content like this. Thanks for watching. See you in the next one.